I think we can start. We have 28 participants in this session. I'm very glad of being here. My name is Víctor Rodríguez Doncel. I'm associate professor at Universidad Politécnica de Madrid. I am with the Artificial Intelligence Department, and I am an expert in semantic web in the league. And it's my pleasure to have in this session 3 great professionals from with very different profiles. I think you can see in your screens already Florina Piroi. Florina is a senior postdoctoral researcher at TU Vienna in the Institute of Information Systems Engineering. She's an expert in knowledge management, deep learning, information retrieval in the patent domain, data science in general. Actually, she's currently coordinating a project on data science and deep learning, IDSDL. We will hear more today. We have also today Waibel, University of Vienna. He's a professor of international law at the University of Vienna. Previously, he taught for a decade at the University of Cambridge. And well, he was also visiting professor of international financial systems at Harvard Law School. And he has a long experience having worked for the European Central Bank, the World Bank, and the International Monetary Fund. The focus of his research is in international law, international economic law, and international dispute settlement. And finally, we have, or we will have, hopefully, Christian Sageder, who is co-founder and managing director of Cybly. This is correctly pronounced. He's a project manager with strong interest in today's topic of data mining in legal documents and contracts in particular. He has also a background on e-commerce projects, mainly mobile applications and online shows. As partner in the Horizon 2020 Links project, which is a project funded by the European Commission, Horizon 2020 scheme, he will also present the project today as a showcase. So, very happy to start. We are a bit delayed. We are 10 minutes late. We do apologize for this delay. So, please, you can start.
So then, if I may start. So, thank you for your introduction, Victor. As you said, I am active in data science, and I am doing also a lot of machine learning and managing various projects and various things, starting from simple data science projects with Industry 4.0 focus to a completely different area into business where we work with patent data and scientific documents from open access collections, and I am also coordinating this Innovationslehrgang, which is a special set of training modules designed for companies, especially for IT specialists, where we try to transfer the knowledge and the latest research results in deep learning and data science into the companies, because these people are working already and dealing with lots of data, dealing with lots of problems which were not really solvable 5 years ago, but now they are. So we are doing this transfer of knowledge from research into the thing. And in relation to today's workshop topic, which is about digitization and digitalization of legal text. Actually, I think in the workshop description it's only written digitalization, right? But I would like very much to make this distinction between digitization and digitalization, because this often confuses people, and lots of project partners they just think that digitalization, yeah, I'm just scanning my documents and I have a set of PDF files and together with my emails and maybe with some Excel sheets and I'm digital, right? no, you're not. This is only making your documents available in some kind of files on your document, but you did not digitalize them yet. You cannot use them yet. This is the next step where you have to process that data and obtain some insights and organize it in such a way that your business profits out of that knowledge you are now having in a digital form. And there are lots of ways to do that, and lots of tools you can use to put this digital content to work. Not last of them, and actually quite an important one, is of course the semantic tools, where Victor is also quite an expert on, and using knowledge graphs and ontologies. I personally work with already digitalized data. So it is already in some digitalized form, and we try to extract information from it and make it useful for various, let's say, retrieval tasks, information retrieval, for example.
Hello.
Okay. Hello.
Finally, I was able to join the event.
I think this is for a start. I would like to pass the microphone further to somebody else.
So I missed the last 2-3 minutes because I had a separate conf call where they helped me to join the event. Because this was, so I don't know where you currently are. So maybe you can guide me a little bit.
So we Victor just introduced us to the audience, and I guess we will let you introduce yourself. He did already tell about you that you are managing the Cybly company, and what exactly you do. I think it's best you tell that yourself.
Okay. Okay. My name is Christian Sageder. I am the managing director of Cybly. Cybly is doing legal tech in the environment, of data analysis and so on. We having one main product currently in the market, which is called Open Laws, which is the portal where you can access European and Austrian legislation content. And based on this Open Laws platform, we have also a mobile app together with the Austrian Council. This is the ReMeP app, which is quite famous here in Austria and is also quite often used. And based on this application, we do a lot with data mining, also with language analysis and so on. So this is the main part where I'm working on. I'm a technical person, so my background is computer science and not the legal part. But since I'm doing this now since mainly 6 years, only doing this legal tech, I have gathered already some knowledge about legislation and so on. And maybe I know from the data point of view much more than other ones which are working with the legislation and case law. I think this is a short introduction from myself today, and I will show today a small demo regarding data mining out of a document and giving an overview also what is behind the scenes and also what is the Lynx project.
Thank you. So I think now it's the turn for Michael, and then he can proceed also with his presentation, if I'm not wrong.
Great. Well, thank you very much, Victor. And I'm also very grateful to my colleague, Erich Schweighofer at the University of Vienna for suggesting that I present briefly a very early stage project that is in fact going to be my very first encounter with, I hope, with computer science, and will, I hope, open up areas for collaboration with computer scientists. So I'm a lawyer. Specifically, I specialize in the law that applies to states, and I'm very, very new to this world of data mining. So I have much to learn, but I have a specific project for which I've recently applied for funding. In a nutshell, this project will be looking at patterns across agreements concluded by states. So I'm planning to look at 15 different types of agreements concluded by states around the world. And for that purpose, I plan to collect a sample of around 12,500 such agreements. Examples would be civil aviation agreements that govern how civil aircraft fly from one country to the other, or double taxation treaties that try to prevent that taxpayers have to pay taxes twice in two or more jurisdictions, but also ensure that taxpayers pay tax in one jurisdiction. And I plan to also look at the evolution of the language in these agreements over time. Probably the time period that I'll be studying is around 150 years. So from the mid-19th century to the present time. There are probably around 20,000 agreements in these 15 areas that I'm interested in, and I'm planning to collect around 12,500. This is, so the sample I expect will be representative of the underlying population. It won't be feasible, I think, to collect all of the agreements, because in some cases they will be very difficult to access, or they may have even disappeared. And in particular, it's likely that it's going to be much easier, or at least less costly, to obtain these agreements and to digitize them. In many cases, they won't be available in digital form for developed countries as compared to developing countries. And what I hope to do is, I'm particularly interested in language that's very similar or identical, that appears in several or many of these agreements. And I'm interested in how this language may propagate from one agreement to the next. And for that, so I want to uncover these patterns in these agreements, and I plan to use natural language processing, network analysis, and machine learning. The plan is to use a training set of about 1,600 hand-coded agreements covering all 15 areas, and to train that on an out-of-sample data for supervised machine learning. I'm also planning to look at agreements in 3 different languages, and I think that will be a major challenge. But if I were to concentrate only on English language agreements, that would be a very significant limitation for my study, and would likely skew the results. So I hope to look at English, French, and Spanish agreements between texts. I'll look into ways of using machine translation to translate the entire sample into English, and also use rules-based text extraction adapted to each of these 3 languages. Now, as mentioned, I believe there will be significant challenges to because of these three languages involved. If machine learning fails, I plan to use skipgrams that capture proximity as an alternative. And if all else fails, to fall back on hand coding a much larger number of agreements than I envisage, that is around 1,600 agreement. Or if it proves to be technically not feasible, to confine the study to English language agreements only. With network analysis, I hope to map and measure relationships across this network of agreements between states, visualizing nodes, which will be the states, and links, the agreements. And I want to then shed light on the network properties of these agreements, statically in the present, but also across time, across the 150 years or so, to understand how these patterns in language and agreements between states diffuse across countries and over time. I plan to then use the data to analyze the data using various centrality and clustering metrics to understand the role of various states in these processes. And that, I hope, will also assist with uncovering the ancestral tree of language that is found in these agreements. So that's in a nutshell what I plan to do. As I said, this project is at a very early stage, and I'd be very keen to obtain feedback on this project, or to hear thoughts on how one could go about analyzing patterns in this corpus that I plan to collect of 12,500 agreements between states. Thank you very much.
That was very nice. What is the scope of this project? Is it who is funding this project?
Well, at the moment, nobody is funding it yet. I have applied for funding.
Okay. I see. So, to see some questions maybe in the chat. So if you want to pose questions, please feel free to. In the meantime, I will pose a question to Michael. You know, I'm a chess player. I like playing chess, and in the last few years, there has been something very nice, and it's that humans and machines have started cooperating. If you want to analyze a game, you put together a team of machines and humans, and they together discuss. I wonder about international agreements. Are machines currently being used? Is there any kind of software that is helping in a negotiation phase? Are you aware of anything like this?
Thank you, Victor. No, I'm not aware of software being used in negotiations, certainly not in the negotiations themselves. And I suspect it may be some time before such software becomes available. I suspect also there may be considerable resistance on the part of, or skepticism at least, initially on the part of negotiators as to the value added, and that may be unjustified, of such software. I have a colleague who has written a program that can write simple agreements. So that, I think that's fascinating, and but I think that's quite a long way off from assisting negotiators in the real world, say, negotiate an investment or a tax treaty between states.
Yeah, because I guess if there is much at stake, I guess that technology will be sooner or later be used to optimize results. So let's see if we have more questions in the room. Oh, Brianna Sims is asking a very nice question. I don't know if you can read it. It's on what happens on countries with a bijural legal system, like Canada. Would it help anyhow?
Yes, I mean, so I think, thank you. It's an excellent question. So I am interested, among others, in exploring what effects, if any, legal origin has on how countries negotiated these agreements and how it influences the content of these agreements. So yes, a country like Canada or Switzerland or Mauritius is particularly interesting. Also Israel, for that reason. Countries like Canada, where the official languages, where both languages are within the scope of the agreements that I want to study, are official languages, is also helpful because it means that I will likely have a significant number of these agreements in both English and French, as in the same agreements in English and French in some cases. And I suspect that's going to be very helpful for analyzing these agreements.
Someone is posing another question to Michael. What could be the benefit for a user of such an application? I don't know what's the user of this application, but maybe you know.
Thank you. Well, I think for at least for the time being, this is quite remote from practice. That is the practice of international negotiations. And this project doesn't seek to directly sort of feed into international negotiations. That said, I do, of course, once the results become available, plan to disseminate key findings to negotiators. And I use a multi-method approach. So I also use qualitative approaches to shedding light on patterns across international agreements. In that context, I will interview a substantial number of treaty negotiators. So I will learn from them about how they go about negotiating these agreements. And hopefully, at least towards the end of the project, I can then also feed back to them what I found and what might be important for them to bear in mind to conclude the best possible agreements for their state. And I suspect it could potentially, but I think that's still a long way off, be particularly beneficial for countries that have limited capacity, countries that have limited expertise in-house about how to negotiate these agreements. So if you think about Namibia negotiating these agreements with the United States, you likely have a considerable imbalance in bargaining power, but not only bargaining power, also expertise, both policy and legal, and perhaps some of the results can go some way towards rebalancing that to a limited extent.
Yeah, very nice. As a comment, I'm sure that you are totally aware, but in the EURLEX portal for law in Europe, you can find more than 10,000 agreements, and many of them in the 24 languages. So it's an incredible resource. So someday you may want to extend from these 3 languages to some others. Analysis. So after the rest of the presentations, we have some time for debate. But first, perhaps we should hear Florina and Christian. I don't know if you have any particular preference. We should start.
I can go. So I think in the context of this event, it would be best to describe my work on using patent data. So my specialty in the last almost 15 years has been to work on information retrieval, and especially on evaluating let's call them search engines, yeah, but they are very different, very specific search systems which are tailored for information professionals. And when I mean information professionals, yeah, I mean, for example, journalist specified in laws, or a patent expert at an office which has to do a search, a prior art search for a patent application, or freedom to operate in a larger company who tries to implement some new technology. So in this domain, in working with patent documents, which these are documents available freely, high recall is desirable. So you do not wish to not find a document. On the other side, there are extremely many documents to search through, and patent experts and professionals in this domain, they spend anywhere from 1 week to 6 months to find the right patents to see if they are allowed to implement a technology, or if they can patent a new technology, and so on. So this has high impact on our society, positive or negative. There is a lot of place to interpret that. Nevertheless, the data is there, and there are lots of people trying to implement search systems for this data, and make them efficient and spare the time of the experts. So I've been working with such data, and I have first-hand experience on how difficult it is to work with it and to search through it, especially because the language has such a specific character. So if characteristics. So if you are searching for whatever information in the general web, you would find maybe some Wikipedia article, you might find maybe some other news article somewhere on a magazine. You would satisfy your need for information. You have learned something what you need, but this is not the case for the patent domain. It's not enough to just understand something on a domain. You really need to find everything so that you are sure that your invention, if you are a company, is not challenged later along the lines. So the language in these documents is very specific, and not only that, but it has different, even different genres. So you have a part which is written by lawyers. These are the claims, and they carry legal weight. And then you have the technical descriptions, which are usually written by the engineers or by the inventors themselves, and they contain a lot of technicalities. And somebody who is educated in the domain would be able to understand and implement that part, or build the part, and so on. So searching in such documents, it's very different depending on what kind of information you're looking for. If you're doing a search for prior art, then you are looking actually on the claims, and those are completely legal content. You need to understand the intricacies, the dependencies between the claims, and how they impact on the validity of a patent, and on the extent of that invention. While if you try to understand just what was done in the area to get an idea of the latest developments in the technology, and sadly a lot of this information is not available anywhere else. You won't find a scientific article describing the newest networking technology, because they are in patents, and these people don't publish it afterwards in any scientific article. So lots of information which is relevant to researchers is actually locked there, because researchers don't know about it. So there is growing interest actually to making this information available also to us. I see myself as a researcher. But this is difficult because the language, even though technical, it's still very specific to the patent domain. they are not using the words we are using in the research. They are using a different language, different formulations. If I would show you the patent on the latest 5G developments, you would not really recognize that it is about the 5G technology. So it is just a completely different language they are using. So the challenge in this domain is to extract this information from these patents, both from the legal side, the claims, and from the technical side, and make it available. Try to extract the information in a nice form for everybody to understand. This is definitely not trivial, and you need lots of specifically designed tools for that. You won't be able to use the BERT algorithms just like that. You would need a specific set of word embeddings to improve on those algorithms and so on. Nevertheless, there is work on it. There are quite many advances lately, and on a good side of this work is that it is now more easier to connect it also to existing scientific publications, because some authors actually also have patents, and then you can use these scientific publications of a patent author and his patent publication, and then try to find out what kind of languages are they using, and try to find connections between them, and maybe use some kind of knowledge graphs behind it to map the information from one side to the other side. So I say one patent side and the other one is a researcher side, to bring these two words together in a more in a form which is approachable for the larger public. That would be my current work, let's say. So if you have any questions about it or more details, I do not know how much. I do not want to go into technical details about it, because I do not know the background of the public watching this. But if you have questions, just send them to me.
Mm-hmm. Let's see if the audience is posing questions. Case for the moment, but I would like to. I'm curious, because how do you fight the giants? I mean, the Waibel has a wonderful search system, the patent scope. The European office has the SpaceNet. They're really powerful search systems. What do you have? I mean, system?
Well, it depends. What they have, it's the huge databases they have behind them, but and they are working a lot to keep them in a curated form. There's really huge effort behind that. Just thinking of how many ways the IBM company name is spelled. If you do a search on that, then you would find at least 35 different ways to spell it. But what these systems have on their websites is, first you get just a limited number of results, while a patent professional will not use these systems, because sometimes they are not even allowed to do a web search. They have to use the intranets and special databases, and they have to get all the documents. So reading 600 documents for them, it's not really unusual. So they really have to go through them, and they do go through them. So just offering them whatever little improvement to reduce that number from 600 to 300, and it is possible to do that if the domain knowledge is included in the system. Then yes, a specially designed search system will improve their lives. In addition, again, these search systems is SpaceNet and Waibel, and I think the German patent office has a system called EPATIS. They usually concentrate a lot on keyword search, and patent writers are very innovative in creating new terms. so that they do not conflict with existing patents. They are really creative in creating new denominations, and then identifying that those denominations actually refer to some previously existing patent or innovation. That's really not trivial, and for that you actually need some linguists with ideally a patent expert too to explain all this to a computer in a machine readable way, so that it is used. So this is quite an intense search domain right now. Research domain, yeah.
I do not know if your answer completely satisfies Günther Reiner, who is asking, what methods do you use to extract information from the patents?
So the best is, of course, we have some kind of digital form, be it an XML file or some text and so on, and then we parse it with various. You can write your own Python script, you can use Perl expressions and so on, but you need to know what you're looking for and how to extract that information. So if you just run an NLP tool and tokenize your text and then extract the simple words, well, that's fine and useful up to some point, but then you need to find relationships between those terms, and finding relationships between those terms, you can think of a Stanford sentence parser, for example, that would find you which one is the verb in your sentence, and then it would find you which is the object of the sentence, which is the subject, what are the attributes. So you can try to extract all that information, but it's still a far away from having useful information, because there is just so much. So you are extracting really tons of data from these patents, and then you have somehow to filter out everything that is useless and keep only that is useful. And then you can, in addition to this, you can get help by analyzing the metadata of patent documents, because they're extremely rich in metadata. They have a lot of information about publication date, about the authors, about countries they're available in. They have a classification system which is very rigorous and very well maintained, and it's extremely helpful to search using those classification systems. Then you have the whole citation encoded in that metadata as well. So you get a network of relationships between patents and inventions and countries. So I've done about a few years ago a very nice study about collaboration between countries based on patents where authors were sitting in 2 different countries, which was actually very interesting to see how collaborations between countries end up in common patents.
Yeah, certainly. I do not want to cannibalize the audience, but I have a lot of questions for you. I will pose a very last one for you, because I'm aware of information retrieval methods from patents, specifically from metadata. And I wonder how to find metadata information from text information, especially now that the European Patent Office has published a very nice ontology for the metadata records of patents, and now all the information is accessible through Sparkle endpoint, so you can make very good structured queries. How do you combine this high quality metadata with the text analytics that you do?
Well, metadata is data, and text data is data. So we just treat it more or less the same. It's in the end, it's the same thing. It's just you are creating then in the end a very smart query, and the crucial part is, and many businesses are actually alive around Europe because of this, is how you prepare the data to ask, to query. How do you analyze your whole patent collection such that you can quickly find the relevant information into that. And this is, you are actually working with really several kind of dictionaries. You have one for maybe only the classification in the patents. You might have one only with the country of origin of the patent. You might have another dictionary only for keywords in the technical description, and so on and so forth, dependencies. And then you would try to query all these ones in one go, and then try to combine the results from all these dictionaries, combine them in some very nice way, smart way. There is lots of research on result fusion, and then show it in a useful way, show it, rank it based on some other algorithms, rank it such that the most relevant ones are on the top of the list, and then decrease by degree of relevance towards the end of the list.
Okay, we will come back to this in the debate, I think. But before, I would like to allow Christian making his presentation. Christian, it's you.
Hi. Okay. I thought I will go a little bit step backward and giving an overview presentation in general. So it was mainly, so what is data mining? Sorry. In general, we are talking today that this is the process of discovering patterns in large data sets. I think we have covered this already, and we want to extract this information with intelligence methods. So this is the main purpose of data mining. Yeah? And most of the time, NLP is currently used of unstructured text for data mining. So I thought I will give you more an overview what is in general data mining and so on, and what is possible. But data mining includes also, and this is, I think we have already a little bit discovered it, also transform the different document formats to a common format we will work with. Because most of the time, maybe also for patents, they are in different formats from the different sources. But if we go, for example, for companies and so on, we have documents in even much more formats. We have Word documents, PowerPoint, Excel, PDFs, and so on, images even. Yeah? And we want to analyze them and want to link them together and getting the right information out of them. So what we want to extract is semantic information. We want to identify so-called concepts within this text. We don't want to find that there's a text. We want to find more. We want to find that this text has a certain meaning that we can take it. Yeah, and also these concepts and so on. We want to map to our ontology or our vocabulary or even to custom dictionaries. So there are a lot of different technologies and tools and data sources used. There is a common term most of the time that it is called, that we talk about a knowledge graph. But a knowledge graph is nothing else than a storage, most of the time in RDF or any other graph database, where we have all this data stored and we have linked the data together. And also we want to, this linguistic information, we want to have two meaningful pieces. It does not help us that we have identified a date. So yes, it's fine that I have identified the 1st of January 2021 in this document, but what is the meaning of this date? We want to know, for example, that this is the creation date, that this is the signing date of the document, or that this is another date which triggers something if in case of a contract or something like this. So we really want to identify more identify meaningful units together and to link them also together, so that we know that the termination date of this contract, for example, is next year, or that it has to be renewed, because otherwise it runs out. And with this information, then we have patterns we can work with. So for example, if we have a contract, we have certain information about the customer or the contract partners and so on. In this case, for example, this contract is a a purchase order or something like this. So we have a customer with its numbers, we have dates, we have costs, one-time costs, monthly costs. We have some clauses inside this contract, for example, for value assurance. And then we have a question. We want to increase the cost to our contract partners, and we want to know which contracts we can, which value we can increase. And if this is not in any ERP system or something like this, but this is only in some contracts which are stored maybe in a CRM system where this information is extracted or stored only as a PDF document, which no additional information, we have to know a lot of information. So which index, for example, is agreed in this contract? What is the interval where we are allowed to increase this index clause? So when the index, what is the month we take for the calculation and base, and so on. So what is the relevant amount of this, what we want to increase, and so on. So these are all of this information. We need to calculate the right index increase for one particular purchase order, I would say. And even we need other third-party information. For example, in Austria, I would need to have the Statistik Austria to get the current value of the index value from the time where the contract was signed and the actual one, so that I can calculate the different one. So this is all. This is the information I want to retrieve from these contracts. And when I have retrieved it, I will store it somewhere. And most of the time, it's stored in a triple store, or this one is a picture of a graph storage. But you can compare them. These are each kind of the same. Yeah. And we have a lot. We have a huge network of information, which then can be queried, and also the information can then be retrieved to give the right answers. For example, if there is a new, and even we want to link this index clause to an information that this is an index clause, so that if there's a court decision about index clausing adjustments or something like this, that we know which contracts on our side are involved. So I want to give you a short demo, hopefully. 1 second. I have to share only another screen. So when I have one document, let's start a different. So I have one document which is only for demo purpose, where I have put in some clauses and so on. And now when I take this and then I ask for analyzation, so it gets analyzed, it immediately downloads. And now you can see that for this demo purpose, we have found certain terms already in it. So we have found references to that this is an offer, for example, that there is the reference to the terms and conditions and so on. Also for the index clause and so on. So this information here in this PDF is only marked. If I would open it also with another PDF viewer, these are annotations inside this document. But the main thing, this information is also available now in a structured form, which can be used at any time and also stored. And this is and linked to the document so that you can query this information. Yeah, okay. So this was only a short sample how information can be structured and what is behind this scene. So we are working on a project. This is called the Lynx project. And the Lynx project, the main object of the Lynx project is to create an ecosystem of smart cloud services and a legal knowledge graph, which is multilingual to provide a base where you can now really start with making application on top of it. The main issue currently is there is a lot of NLP services in the market, but the main thing is all of them or most of them are trained first of all for English, because this is the one they coming most of the time from the US. So you have always them for English language. The second thing is they are most of the time, for example, normal bird models and so on, they are trained with newspapers, Twitter, and so on. So they are not trained or make use of a legal document or even patents and so on, which uses a totally different language. You can take, for example, a sentenizer, which should recognize sentence in a document, which is normally trained for, let's say, English, and use it already in a German document. So it will already fail because it will have some issues with the acronyms. But if you take it and use it on a legal document, you will have a lot of nice sentences, which are not sentences anymore, because it fails totally. Because they were trained for short English texts and are not used to have a text, a sentence which goes nearly over half a page because of it's a legal document. And this is the reason why Lynx is doing it in a different way. So we train the system based on legal information. And to have this, we provide an ecosystem which has differences. We have different sources. We have legal resources, which are the different countries we currently support. In the pilot phase currently, we are supporting 4 countries with 4 languages: Austria, Germany, Netherlands, Spain, and Dutch. We have language resources. So we have, for example, language resources. We have dictionaries, not only monolingual dictionaries, also multilingual and bilingual dictionaries, which can be used, which are generic one. And we have language resources also for translation, automatic machine translation, which are trained really for legal documents. So they are also taking as main corpus, for example, also Eurolex and also other legal documents from the different countries. So they are getting trained that the machine translation is in a higher stage than a normal automatic machine translation would be. But you can also add standards, which is in this case used for one pilot here. And you can also add private documents to this knowledge to this system. When you're adding documents, they normally run through a process where these documents get annotated with different services. And the smart services, here's a short summary. This is not all of them. Yeah. We have semantic annotations. We have linking, summarization, translation services. We have even a multilingual search, so you can search in the system by typing in a query in Spanish, and this it still is looking into German and Dutch documents, for example, or English documents. So you don't have to be able to talk the language the documents are from most of the time. This is the reason, for example, if you type in something in Google, you will find the Google documents which are in the same language, but you will not find documents which are in another language, because your query will not be translated. We have QA services, and we having in the knowledge graph, we having an ontology, terminology for the for different domains. For example, labor law, or for another use case which is more concentrated on the pilot of geothermal, and one, for example, which is ours, which is mainly based for the contracts. You can build with these services workflows, so that you can say, when I have a document, it will be analyzed, and will the analyzation should be go through certain levels. I think, yeah. So, for example, in the pilot, we have a pilot. This is the one from Cybly Open Laws, which is the contracts pilot. So we try to analyze contracts and extracting all of this meaningful information out of the contracts, and want to link them to the particular norms, so that in case there's a change in the legislation, that you are aware which contracts are affected. So this is what we try to do in this pilot. And also, what an interesting point is also, we want to build a summary page for each contract. So in case you have you are in a company which is located in several places across Europe, and you are in the legal department in Austria, for example, and you're getting a contract from Italy and you don't speak Italian, so you should get at least an English summary of the contract, so that at least you know that this is a rental contract and or a non-disclosure agreement or something like this. So how this should be look like? We have documents in multiple formats, so they will be normalized, and the text will be extracted. We do knowledge extractions with link services and also with own build services, building some document structure. So we build a knowledge graph. Also, beside the knowledge graph within the link services, we also build a local knowledge graph of the private documents for one customer. And based on this, we provide then the output. For example, we can also then provide answers about termination, expiring dates, and so on. So this is, for example, a workflow which can be put up. The workflows can be switched together in a flexible way, so they are not hard-coded. So you can really draw your workflow and define how a document should be processed in the system. For example, this document structure analyze, entity extractions, work sense inductions, and so on. Geolocation, and because based on the geolocation, you'll find out, for example, the restrictions and so on. This and then finally, you get, for example, a translation of the document and even a summarization, so that you have a summary about the document, and it's fed to a search engine, which is customized, which then allows you to search through all the documents within this system. In case you are interested more about the links, there is a homepage, which is links project EU. 1 second. So on this project, you will see the information about the project. We have all the resources. You see the APIs. There is the API description of the different services you can have. For example, for temporal, there is also Swagger, for which one are more interested already in implementing something or getting some documentation. There are also links to the publications about this project on the different services. But you will find also our data model, how it will look like. So we have defined how a legal document will look like in the system and so on. So this gives you already an entry point how you can start with the Lynx project. Any questions?
It's a very complete presentation. A couple of questions in the chat. For example, Mirabella Metzler is wondering whether it's possible to read various types of documents. I think she was referring to the previous demo.
Yeah, so the demo can we can read PDFs, Word, Excel, so really all the different document formats. In the information extraction, they are all of them are reduced to text, but this is no problem. We even having functionality of OCR, so even if these documents are only scanned and not available as electronic PDF, they will be OCR'd and also getting through the process.
That's very nice. There was another question on language. So, sorry, Mirabella still is asking about images.
Yeah, so images, yes, but we currently extracting only the text information out of the images. We are not extracting image information like this is a bread, this is a sign or something like this. So this kind of functionality we don't do. But if this is text inside the image, so if it's, for example, an image scan, the text will be extracted and then analyzed.
That's very good. We have another question posing questions. SE. This person, she or he, was wondering on the languages, whether you could work with German, for example, but which other languages?
Yeah, we are working mainly with German. As we are a German an Austrian company, so German and English is preferable. But I'm getting now also used to Spanish, as this is led by UPM, which are located in Spain. And from a processing point of view, it's independently if it's English or German or Spanish. Most of the time, it's for me mainly difficult to qualify the results because I'm not able to read the Spanish document. So, but there are other persons in the project which can speak Spanish perfect, for example.
The same person also was reading attachment to emails. Yeah, this would be very nice if you could simply drop an email, drag and drop an email, and make it being analyzed. But
this is possible, yes. You can drop an email with all its attachment, and we do it for an Austrian company, which is on the Austrian stock. So they're really analyzing their email system, their emails, and they having funny things. They have emails with attachments, which are emails with attachments, which are emails. The longest path I found was 15 steps inside where an email was inside an email, where finally documents were in. So I don't know who is writing this kind of emails, but they are doing it. And this is really done. So these documents are put together, and in this case, we are looking for certain documents in these attachments.
Mm-hmm. That's very nice.
Christian,
Any other question?
if I may, sorry, I do have a question because
Yeah.
at least in the patent documents, especially for the older ones, which still need to be found by search systems, we fight a lot with the scanning and OCRing errors, because some of them are clear, they don't really exist in a digital form. They were at that time only printed, and at some later point they are scanned and OCR'd and so on. And the errors there are not negligible, and they have some impact on how the data is mined and processed before being retrieved. So what is your experience with this in this aspect, in this respect?
Yeah, I have to say I'm lucky because most of the documents which we process currently, which are scanned, most of the time only scanned because of signature and so on. So they were just printed out, let's say, in shortlist printed out, signed, and then scanned and then emailed again or something like this. So they are quite new documents and they having not all of this noise. But I know from other projects that this is a huge issue, having all of them. I know in Austria someone which has a huge experience there, scanning this kind of documents and OCRing them. It's the Austrian Parliament, because they have to do it with. So they have to digitize all their documents before they starting renovating the Austrian Parliament, and they really have a lot of experience there. So if you want to go more, maybe they can help you. But they have also these scanners ours don't have. I think they're costing several €100,000 for scanning documents, for example. And they're having even the old phones. So not they are trained even for older typography. Which is most of the time also an issue with older documents. So if you go into the past, I think this is getting more and more difficult.
Mm-hmm. Mm-hmm. That's very nice. Any other question for Christian? Then I have a question to the audience, if this is possible. We heard the first by Michael on international agreements, then on Florina, searching patents, and the final one on Christian with contracts and the links project. Do we have in the audience someone who is expert in one of these three different domains? If so, I would appreciate if we manifest it in the chat. In the meantime, I will make another question for the three people here connected. We have still 15 minutes before we finish the session. So the first question is the audience has not reacted. The first question is more to Michael. How do you find, Michael, technology providers? If you now you are dealing with technical problems, what's your first instinct? To go to the big giants, to go to IBM and look for solutions, to look for startups that are more dynamic, to look for universities? What is most attractive for you?
Thank you. So I'm not really at that stage yet, but I think my first instinct would be to go to smaller players. But I found it very interesting what Christian just said earlier, that the Austrian Parliament has a lot of experience also with older documents. That might be quite useful for my project as well.
Yeah, but probably also in terms of language, yeah, the language that is used in these documents, I guess. Can imagine. Do you also work, Florina, with old patents? You only work with recent documents, isn't it?
I think the oldest patent we have in the collection is somewhere 1930 or something like that. It's not really useful, right? So this, because if you look at patents at that time, so that the collection I've been working with and doing evaluation campaigns, running evaluation campaigns on them, you included only European patent data, but US patent data, they have even older patents. It's just that the patent law changed so much along these years, and the regulations, how these were published, changed so much that the patents, like in 1930s, are sometimes maybe one or two pages long. So it was really more like a letter of trust from the government that and giving rights to a specific company, but the invention disclosure was not that detailed as it is right now. So those patents are very interesting to look at. It's really fascinating also to read the text and how they read it there. But yeah, we still have to search through them because they sometimes belong to background information for some new invention. It's surprising, but they do. But the most challenging part is actually trying to make sense of the metadata, especially the names of the authors and the names of the companies and all this. There is really a mess there often, and just to figure out that two names are actually referring to the same person, this is really not trivial. On n-gram, on charactergrams and so on, algorithms to try to match these things, it's often not quite enough. So you really need to be very smart in that, also because the expectations are quite high in this domain. So this type of data mining of this metadata, it sounds simple, it's easy to define the task, but it's very complicated to solve. So you need to analyze lots of different facets of a document to really conclude that these two entities are one and the same company.
That's very nice. I will go first to the second one because Veronica's question is more related to the last comment. So Veronica, that they did a project, legal network analysis with real-time PDF annotation, drawing citation network graphs to explore the context of European case law decisions. Do you also, Florina, graphically, visually, the connections between the patent, which one or something like this?
We didn't have to do that. So this is called patent landscaping and on the scene, and there are many companies doing that. But it's very often task based. So I'm interested in quantum computing, and I want to see what happenings on that. So creating a map of the whole patent domain, it's close to impossible, but you can concentrate on one technical area and explore that using that. We didn't use these kind of networks to visualize, but we did use these networks, these patent networks, by looking at families and citation networks and forward and backward citations and so on. So we did use that to exploit even further, to do some more deeper data mining on the documents.
Mm-hmm. I see. So each of these contributions, contribution of Michael, Florina, Christian, they are very nice individually, but for me the most exciting thing is that we are here all together with such a different background. Christian in a small company, we in the university, different domains, you are a legal scholar, computer scientist all together. And I would like to thank ReMeP for joining us here together. I think this is a need, and this is exemplified by the comment of Brianna Sims, who was asking in the chat legal advice or what to do. She had a legal background, how to go to the legal tech space. I do not know how to answer, but I do appreciate the efforts of organizations like Legal Hackers or ReMeP, who try to bring together these apparently different worlds. I think there is a need for this, and even to include more people. For example, in this case, maybe we need always experts in visualization, yeah, to display graphical information. I don't know if Stefan Eder is connected and wants to make a comment on the future activities of legal hackers in Vienna or not. But if I think if you stay tuned to ReMeP and legal hackers, you will soon find suitable events, Brianna.
So if I may answer that, personally, I think it's easier the other way around. So being a computational linguist or having some kind of computer science education, it's maybe a bit easier to go to the legal domain. The other way around, you can't escape learning to code a little bit to understand the principle of programming and so on, to understand the challenges of handling this amount of data and how and what the potential is to look at that data and try to use it in some smart way. In all our projects, like the one Christian described, the one I am involved with, and I didn't mention all of them, which are text related, expert knowledge is really crucial. Yeah? So we lack this. We don't have access to the legal persons because they are first expensive, so it's really not easy to get to talk to you people, and then we really have to work on a kind of common language, and this ReMeP event, I have to say, it's really one of the best ones to do this, to understand somehow both sides.
Mm-hmm.
So
yeah, I can also say, so it's necessary to have, let's say, lawyers also in the team, because they help you to understand what you're doing. Because for me, for example, there is always these nice examples here in the Austrian legislation. There is this term publicity, which is defined, I think, in multiple different legislations. So, and it means one time 3 are already public. The next time you need to have 50 people that it is public, and so on. So this is really a fascinating thing of me. And they make you also aware of some funny facts when you do the first time analysis. It's like, I noticed there's acronyms for this legislation here in Austria. They are reused multiple. So, and they are really, this is a funny thing. Because if you have, for example, from the Austrian REIS, if you go into the normal public legislation, then you find something like this is acronym with MUSC, which is called Musterschutz, and this is the main thing for many patents. But there's also, again, the same acronym is used for legislation, how to prevent pregnant mothers. So you have to be aware about it.
No, this is not fair, Christian. I do think that we computer scientists, we have more acronyms. But okay, so we have been requested to...
Just one very important comment, which actually Christian reminded me. It's extremely important when you do data mining in legal text and so on to think about accountability and reproducing your results, because if you give a decision to your patent expert and then they ask you in 2 months, hey, I have a court case, how did you get that, and I need more extra information, this is extremely important, and do not forget about it. It's really critical in many areas in this in the legal tech domain. So I
That's the comment.
yeah, thank you.
So we have been requested to abandon this session. Anyway, it's 8 o'clock. And you should join the main stage for the wrap-up session. So technically, what should I do? I guess it's just abandoning the room and joining the stage. So we meet in the other room without coffee.
Thank you.